In this video, I'm going to show you how you can implement and when to use an object pool. Object pools are used to reduce the number of memory allocations a game has. In Unity, when creating a game object, memory is set aside for that object. When the object is later destroyed, the memory has to be reclaimed through a process called garbage collection. Allocation and garbage collection are somewhat heavy tasks that can take a significant amount of time. Further, garbage collection is something that we, for the most part, don't have direct control over, so we don't know when it's going to happen. This can cause unexpected delays. Object pools avoid this by recycling. Instead of throwing away an object when we're done with it, we just mark it as not in use. Then, when we need a new object, we take this object that's been marked not in use, dust it off, and reuse it. This does mean that more memory might be in use throughout the course of your program, but it's typically worthwhile since memory usage is more predictable. Let's take a look at some code. Our GameObjectPool class is going to manage pooling all of our game objects. It's going to have a maximum number of objects to pool, as well as an option to pre-allocate some objects. It's also going to have a game object that we're going to use as a parent for organizing pooled objects in our scene. It's going to maintain a list of pools referenced by a prefab name. Each pool contains only one type of prefab, so that when adding or removing from that pool, we know we're going to get the same object out that we put in. When spawning a new game object, we're going to check to see if our pool has any game objects in it. If it does, we're going to remove from that pool. Otherwise, we're going to instantiate a new game object and return that. Removing from the pool pops the game object off our pool stack, resets its transform values, and sets it to active. When adding a game object to the pool, we're going to set the object active to false, and then set the parent to our object parent for organization. Lastly, we're going to push the object onto our object pool stack so that it can be popped off when we need a new object. For this demonstration, I'm going to use two types of objects. I'm going to create bullets that will recycle themselves when they've finished, and bullets that will destroy themselves when they've finished. The test interface I'm going to use is simply going to create a number of destroy bullets and a number of recycle bullets, and then compare the runtime for creating each group of objects. When starting a pool run, we're going to start our timer, run through the number of items we're going to add, and spawn each game object using our game object pool. When doing an instantiate run, we're going to run through the number of objects and use gameObject.instantiate. Hitting the space key will start our test run. Let's take a look at this in Unity. Here we have our pool tester that's going to have a specific number of objects to spawn, and hitting the space key will spawn those objects. We see here that our first run, the instantiate and pool runs, are very similar in times, with instantiate being slightly lower. But now that we have objects in our pool, we can see that the next run is significantly better for the pool run than the instantiate run. Additionally, we can increase the number of objects and see similar results, where they'd be fairly close in the first run and significantly better for the pool run in the future runs. In this video, I've taught you how to use pools and what they're used for. The reuse of objects provides significant performance improvements for CPU and RAM usage. We can likely improve the pool system we've created here for better tracking of different types of prefabs instead of using object names. Further, we can add support for prefabs that have different startup values. In games where a large number of objects are going to be created over and over again, pools are essential. Pools are also fairly important on systems with limited resources, like mobile or web. Reducing the amount of garbage produced by your game reduces the frequency of garbage collection in addition to reducing the impact it has. Unexpected performance drops are frequently caused by garbage collection. Pools are an essential step towards implementing the 3 R's in your development: reduce, recycle, and reuse.